Yeah. So in the last class, I was talking about the dynamic programming problems. So we have discussed the different methods of dynamic programming and multi-decision problems also. And also, we were talking about the uh, computational procedure which is involved in dynamic programming problem in the last class. Okay. So in today's class, let us take you for one important problem type, that is what we call it as how we can use dynamic programming technique for solving a linear programming problem. Okay, it is a very important question from the examination point of view. Maybe around 8 marks. One question will be there, so both for linear programming and non-linear programming problems. How we can use the dynamic programming problem or dynamic programming approach. Okay, so that is what we are going to solve one or two problems. If possible, we will solve two problems today. Okay, so before going to that dynamic programming problems, solve problems, we are going to start with the methods of solving the dynamic programming problems. There are two approaches we generally employ. One is called a forward recursive approach, and second one we call it as a backward recursive approach. So, in the forward recursive approach, the computations are carried out from the first stage to the last stage, whereas in the backward recursive approach, the computations are carried out from last stage to the first stage. So this is what the methods what we're going to adopt for solving a dynamic programming problems, especially for linear programming or non-linear programming problems. So forward recursive approach and backward recursive approach. So we generally use backward recursive approach. That's what I was talking in the last two classes on dynamic programming. So we're going to start from the last element and we're going to move to the first element. So we're going to start with the last element. In the sense, last element will be considered as the first for sub-optimization, and later onwards we're going to club the next previous one. We're going to sub-optimize like that. Each one will be sub-optimized by just grouping the each one. So then we will going to get the entire the system will be get optimized. This is the same procedure what we are applying here also. Okay, so we're going to take a few problems on how we can use the dynamic programming technique for solving both linear programming and non-linear programming. So this is what I wanted to solve. This is a one question definitely will be there in your exams for 8 to 10. Okay. So this is what application of dynamic programming problems to linear programming. Okay, so I'm going to start it now. Okay, so you can take a notebook and pen, and you can note down the question, and we're going to solve simultaneously. Okay. Yeah. So please note on this question. Yeah, this is I think clear. Please note on this question. Application of dynamic programming to linear programming. Yeah, please you can unmute and you can interact with me whenever you find it difficult. Can you able to see this?
Yes, sir.
Please note on this. This is the problem statement. The problem is maximize Z. It is Z actually. Maximize Z, which is equal to 8x1 plus 7x2. Maximize 8x1. Z is equal to 8x1 plus 7x2. Subjected to a constraint. Subjected to a constraint 2x1 plus x2. 2x1 plus x2, which is less than or equal to 8. Less than or equal to 8. And 5x1, second constraint, 5x1 plus 2x2. 5x1 plus 2x2 less than or equal to 15. 1, 5. And general constraint is x1 and x2 should be always greater than or equal to 0. It is a non-negative number. X1 and x2 are non-negative numbers. So this is a typical problem for dynamic programming, the application of dynamic programming to linear programming. Okay. So how we can solve this? How we can solve the linear programming by using the dynamic programming technique? This is one what we are going to discuss in for today's class. Okay. So what we have to do here is whenever they have given any problem in linear programming and we have to make use of dynamic programming technique. So first you have to check it out for how many number of variables are there here. There are variables in the sense, I mean to say it is a decision variable. Okay. Always the word variables in this chapter, which is refers to the decision variables. So in this case, in the problem, so the number of decision variables is given in the problem is equal to 2. So what are those two decision variables are? So function is z. Z is equal to 8x1 plus 7x2. So there are two decision variables. Some net connection problem was there. Just got it. There was some internet problem. Yeah. So here function is z. Z is equal to 8x1 plus 7x2, which carries two variables x1 and x2. So two decision variables. The function is having two decision variables x1 and x2. Okay. So therefore, so what we have to do here is, so there will be two stages. So when you have two decision variables, the number of stages will be 2. So depending upon the number of variables, you will going to have the number of stages. In the sense, number of stages is equal to the number of variables. So if you have 3 variables, you will have 3 stages. If you have 4 variables, you will have 4 stages. This is how you are going to just start the problem. So first thing is you have to look it out for how many number of variables are there in the function, or if the function is there or consisting of how many decision variables. So based upon the decision variables, we will going to get the number of stages. So in this case, the number of decision variables are 2, which are x1 and x2, and hence the number of stages will also be 2 here. Okay. So here the stage 1, that is stage 1 is assigned to the decision variable x1 and stage 2 is assigned to the decision variable x2. So the two stages we are going to assign it. The first stage is assigned for x1, the variable x1, and second stage we are going to assign it for x2. Okay. So here in this case, especially for linear programming or in a dynamic programming, we generally use the backward recursion method. So we're going to use the backward recursion method only in the case of the application of dynamic program to linear programming, and we will going to get the solution for the problem what we are given here. Okay, so we are using the backward recursion method. Okay, so when we use the backward recursion method, in the sense we have to start from the last one, the stage 2 we have to start, and then we have to proceed to the stage 1. This is what the backward recursion method stage. So in this backward recursion method, so the computation starts from the last stage and it will move to the first stage. So therefore, in this problem also, we're going to start with the stage 2. So stage 2 is the last stage in this case, and later onwards, once we get the optimum values for the stage 2, then we will go to proceed it for the stage 1. So this is the method what you're supposed to follow. Okay. So therefore, you can write it as n is equal to 2. So you can see here n is equal to 2. The number of stages are 2. Okay. So in this, you have to have certain the resources we are going to call it as. This is the one step what we are going to use it in our backward recursive method or application of dynamic programming to linear programming. So B11, so what we have shown here. So B11 represents the resource 1 consumed in stage 1, and B21 is the resource consumed in resource 2 consumed in stage 1. Please understand this is, so there are two stages here. Okay, and B11 corresponds to the resource 1 consumed in stage 1, and B21 is the resource 2 consumed in the stage 2. So when you are writing these values of B, the first suffix represents the resource type, resource number, and the second suffix represents the stage number. So please remember this. So B11 corresponds to, the first one corresponds to the resource, and second one corresponds to the stage. So in this case, we have two stages and two resources. So B11, the resource 1 consumed in stage 1, and B21 is the resource 2 consumed in stage 1. This is for the stage 1. And moving on to the stage 2, it is B12. B12. So resource 1 consumed in stage 2, and B22 is the resource consumed in stage 2. So like this, you have to write out the resources what you will going to have. Since we are having only two variables, so you will going to have only 4 resource variables will going to get it. Okay. So if you have 3 variables, it is 3 square. It is means 3 nines you will going to have like that. So the number of the resources you will going to be used will be square of the number of variables what you are having. So like this, you will going to get it this. Okay. So now, so this is what we are going to get B11, B21, B22, and B12. So this is the one first you will going to write it down. So please make a note of all these things. Okay, so you should know to, of course, these things will remain constant. Only the next thing what we're going to start, we're going to change for each and every problem. Only thing you have to decide how many number of variables are there and how many number of stages. So these two things is decided, and based upon that, you can get the resources you can allot. Okay. So now let us take F2. Okay, what is F2 here? F2 corresponds to the recursion function for the stage 2 by considering the variable x2. So we're going to assume F2 as the recursive function for the stage 2 by considering the variable x2. In the similar way, we have F1, which is also recursion function for the stage 1 by considering the variable x. Okay, x1 and x2, sorry, f1 and f2. F2 and f1 are the recursive functions for stage 2 and stage 1 respectively. So this is what you are going to assign it in the beginning. Okay, next comes, so this is a very important step for us. So what we do here is, let us take the stage 2. So because we are using a backward recursive approach over here, so we're going to start from the backwards. Okay. So now what we are doing is, let us assume or let us assign the F2, the recursive function for stage 2, by considering the variable x2. So means we are going to start with the last, only the last element or the last stage over here. So therefore, we are taking F2 is equal to maximum of 7x2. So where you have what 7x2 means the function. See here the function here. Okay, z is equal to 8x1 plus 7x2. Am I right? So we are starting with the last stage over here. So 7x2 is the function, a recursive function for stage 2, considering the variable x2 only. So therefore, F2 we will go to assign it as maximize, we will say. So F2 is equal to maximum of 7x2. Okay, so this 7x2 will be the x2 varies. So because x2 is the resources which will be consumed in the stage 1 and stage 2 here. So x2 is equal to, x2 lies between 0 and b12. So this is what we have assigned the resources what we have taken here. So for stage 2, there are 2 resources we have assigned. One is b12 and b22. So therefore, so the constraint value for this stage will be x2 will be lying between 0 and b12, and the second one is 2x2. So you say x2 means, you look at here. So in the constraint phase, the stage 2 will be x2 only. We are taking only the x2 constraints here. So therefore x2. So in the first stage, what you are getting x2 as plus lying between, it is 0 to b12. And in the second stage, x2 it is nothing but 2x2. So these resources are 2x2, which will be less than or equal to b22. So please remember this. This is how we will going to write the expressions for the recursive function for the last stage. That is second stage. What we will going to do. So how do you write? So first one is the f2 is equal to maximum of f7x2. So this is the second stage function, recursive function, and then the value of x2 will depends upon the resources what it will going to consume. So that is in the first stage x2 value will be lying between 0 and b12, and in the second stage the value of x2. So this is second equation. It is 2x2 is given. So therefore 2x2 lies between 0 and b22. So this is what we have written here. Please understand this expression. If you know how to write this expression, things will be very easy for you. Okay. So this I think you can understand. I think people are following. Any clarification is there, you can stop me at any time, anybody, and you can clarify your doubt. Okay. So now to maintain the feasibility, x2 should be minimum of b12 and b22 by 2. So because it is 2x2 is there. So therefore, what they are going to do to maintain the feasibility, x2 should be minimum of. So it should be the value of x2 should lie from the minimum of b12 and b22 by 2, because it is 2x2 is less than or equal to b22 over here. So therefore, 2 we are going to take it into the denominator. It will become b22 by 2. So therefore, the above objective function is modified as follows. If you understand one problem, the rest of the problems will be very easy. So please follow the procedure, understand the procedure clearly. Okay, then you can move easily. See, to have the value of x2, the x2 value should be have the minimum feasibility. So the value of x2 should be minimum. So it should be value should be minimum of these two values. So in the sense, x2 should be a minimum of b12 or x2 should be minimum of b22 by 2. So any one of these two values will be the minimum value for the x2 what we are going to get. Okay, I'll proceed for the next one. Next step, yeah, here. Therefore, what we are written here is f2 is equal to 7 minimum. So we are substituting the minimum value of x2. So f2 is equal to 7 of x2 we have taken here. x2 value should be minimum value. So minimum of b12 comma b22 by 2. I hope you're following. Any clarification, anybody? Please follow the steps. Please start writing down the steps, each step, because it carries 8 to 10 marks in your exam. One problem definitely will be there in module 5. Okay, f2 is equal to 7. So previously what we have written, it is 7x2. Am I right? Maximum of 7x2. Now f2 we are going to write it as 7 minimum of the value of x2. Minimum of s of x2 means x2 can have a minimum value of either b12 or b22 by 2. Therefore, x2 we will going to write it as minimum of b12 comma b22 by 2. So this is a very important thing. You are supposed to get the conclusion for x2. Okay. So next, this is the completion of second stage. In the sense, so in a broader way, if you want to understand this, we have sub-optimized the last stage now. So this is what we are done for the water tank example, what I discussed. So we started sub-optimizing the foundation, then we move to the pillars, then we move to the tank. Okay. So what we have done is, first we have sub-optimized the foundation, and then we group the foundation and pillar. Then the next stage we have sub-optimized this, and in the third stage what we done, we grouped all the three, that is foundation, the pillar and the tank, and then we start sub-optimizing. So in the similar way here, the two stages are there. Stage 2 we have sub-optimized now. Now what we do is we group 1 and 2 and we start sub-optimizing now. So this is the same procedure how we can we discussed for in the case of a water tank example. Okay. So in this case, So this is, we are completing, we are getting the minimum value of or optimum value of x2. It should be the minimum of these two values. Any one, two values are there. So minimum of these two value will be the x2 value for us. Next comes recursion function for the stage 1. So now we are moving on to the stage 1, which consists of both stage 2 and x2 and x1. Both we club together, we will go to write the recursive function now. So in the recursive function for stage 1, with respect to s, f1 is max of. So just move to this expression here. So what's happening here? So it is 2x1. Yeah. See, maximum of C. This expression I will write max of 8x1. You can see here 8x1 plus 7. That's stage 2, where you are suboptimized. Stage 2, 7 minimum of B11 minus 2x1. So why I am writing B11 minus 2x1 over here is, see, B11 is the resource consumed in stage 1. Resource consumed in stage 1. So resource 1 consumed in stage 1. See, already we have suboptimized this stage 2. So stage 2 element already consumed some amount of resource. So therefore, what we can write over here in this case, it is B11 minus how much amount of 2x1 is here? 2x1. So please be careful while you are writing the expression for recursive function 1, you should be very careful. So it is B11 minus 2x1. So we are going to get the resource for, we are going to express it for the minimum of 2, and B21 minus 5x1 by 2. So this is how we are going to write the recursive function for the stage 1. So where, so x1 lies between B11 and 5x1 lies between the 2x, B1, B21. Okay. So 2x1. So the same thing how we discussed for constraints here. It is 2x1. Okay. So x1 lies between 0. Sorry, 2x1 lies between 0 and B11, whereas 5x1 lies between 0 and B21. Similarly, how we written for the previous the recursive function f2. Okay. So now, so this is how we will go into write the expression now. So what we say here is the stage 1 is the last in the series of the backward recursion. So therefore, we will go to write B11. We are going to assign the value of B11 is equal to 8 and B21 is equal to 15. So what is B11 and B21? How we get these values B1 and B22? It is in the range values what they have given. See, the first constraint it is given less than or equal to 8, and second it is less than or equal to 15. So since the stage 1 is the last in the backward stage, so what we do here is we're going to assign the values of the B11 as 8 and B21 as 15. So this is the procedure what you're supposed to remember and you're supposed to follow. Okay. So in the recursive function f1, so where the value of b11 is assigned with the value of 8, whereas for b12 we are assigned with b21. Sorry, b21 we assign the value of 15 because the stage 1 is the last in the recursive or in the optimization group over here. Okay. Yeah. So now what we have done, B11 is equal to 8 and B21 is equal to 15. Okay. So now just substituting in this equation here. So 0, 2x1, 8. So in the previous one it was 211. Since we have assigned it as 8, I am substituting B11 as 8 and B21 as 15. That's the only thing what we are doing over here. Substituting for B11 and B21 in the above expression. B11 and B21 as B11 as 8 and B21 as 15 in the above expression. So when you just substitute that value, so now we have, you see 2x1 means we can make it as x1 is 8 and 5x1 is less than or equal to 15 means x1 will be less than or equal to 3. So it is 2x1 is less than or equal to 8 or x1 is less than or equal to 4. Then 5x1 less than or equal to 15 or x1 is less than or equal to 3. It is also same over here. So now, so in the expression we are substituted. Now we have a recursive function f1 as 8x1 plus 7 of minimum of x2. Minimum of x2 will be this value. 8 is the b11 what we have written in the previous one. 8 minus 2x1 comma 15 minus 5x1 by 2. This is what the recursive function what we will go into get it. Okay. So in order to get the feasibility, again, in order to get the feasibility, okay, so we have to consider the minimum value or the minimum range for the variable x1. Minimum range for the x1 variable over here. So here, so x1 can have a value of between 4 and 3. See, x1 varies from 0 to 4 and x1 varies from 0 to 3. Okay. So out of these two values, so in order to have or in order to maintain the feasibility, okay, so we need to consider which will have the minimum range. So in these two, the minimum range is x1 lying between 0 and 3. So therefore, we are going to consider the minimum range of the x1 here and we will go into solve the problem. So what is the minimum range? It is x1 lying between 0 and 3. So this is what we have taken. So therefore, we are going to rewrite the recursive function f1 is equal to maximizing where x1 lies between 0 and 3. Okay, and the rest of the equation will remain same. 8x1 plus 7 of minimum of 8 minus 2x1 comma 15 minus 5x1 by. So now what we have to do? So this is the final equation for us. So now we have to get the values of x1 and x2, x1 and x2 in such a way that f1 will be maximum. x1 and x2 should be minimum value, but f should be maximum. This is how we will go into solve the problem. So how to get that one? So it is just like a iterative process. Iterative process in the sense you will be keep on assigning the value of x1. So x1 range is 0 to 3 in this problem. Okay. Within 0 to 3, you will keep on giving the value to the x1 value. And simultaneously, you will going to get what is x2. And correspondingly, you will going to get the f1 value also. F1 value also. So once you get the F1 value, so you have to check which will have maximum F1 and correspondingly for that minimum of X1 and X2 we supposed to get it. So how we will going to do that? This we will going to see. This is the final equation for us. Okay, so where X1 value will place between 0 and 3. So now what I do here is we will go into assign the value of x1 for this. I will put x1. X1 can be equal to 0 also. I will going to put x1 as 0 in this expression. If I put x1 as 0, if I put x1 as 0, so what happens is first equation we have put for x1 is equal to 0. F1 is equal to maximum of 8 into 0 because x1 is 0 plus 7 of minimum of here 8 minus 2x1. So it will become, this term will become 0. So therefore you are going to get 8 comma second term. If I put x1 is equal to 0, so this term will become 0 and hence 15 divided by 2 you are going to get 15 divided by 2 is nothing but 7.5. Okay, so this is what we have written over here. If you look at here, so maximum of 8 into 0 plus 7 of minimum comma 8 comma 7.5. So out of these two, 8 comma 7.5, you have to select the minimum value. So which is the minimum value? 8 and 7.5, it is a 7.5. So therefore 7 into 7.5. So totally F1 will become 52.5. 52.5 you will go into get it. In the similar way, you have to strive for x1 is equal to 1, x1 is equal to 2, and x1 is equal to 3. So maximum is you can get up to 3. So in between you can try. You can try 1.5, 2.5, 3.5, 1.1, 1.2, not an issue for us. But what we want is f should be maximum, okay, and you should go to get the minimum value of x1 and x2. This is how we will going to solve this problem. Okay. So what we do, so you can try with x1 is equal to 1. So just looking at, I think you can try at me. I will just explain here. If you put x is equal to 1 here, so what happens to this equation now? So 8 into 1 plus 7 of minimum into 8 minus 2. 8 minus 2 into 1, it is become 4. 4, comma, 15 minus 5 into 1. So 15 minus 5 is 10, 10 divided by 2, it is 5. Okay, so what you will going to get is 8 plus 7 minimum of 4 comma 5. Okay, so just 4 comma 5 means minimum value is 4. We're going to take, so in the equation what we're going to write is 8 plus 7 into 4. 8 plus 7 into 4. So 7 into 4 is 28. 28 plus 8 is 36. So the value of f1 will become 36 volt. Similar way, you can try with x is equal to x1 is equal to 2. x1 is equal to 2 and x1 is equal to 3. So look at here. When you put x1 is equal to 3 here, so substituting x1 is equal to 3 here, 8 into 3 plus 7 minimum of 8 in minus 2 into 3. 2 into 3 is 6. 6 minus 8 is 2. Comma 15 minus 5 into x1. 5 into 3 is 15. It will become 0. So 8 into 3 plus minimum of 2 comma 0. Minimum of 2 comma 0, we are going to take 0 only. This will become used. So when you put x1 is equal to 3, you are going to get 24. So like that, if you put x1 is equal to 0, x1 is equal to 1, x2 is equal to 2, x1 is equal to 2, x1 is equal to 3. From 0 to 3, you have to keep a trial and you should see for which value of x1, the f1 will become maximum because you are maximizing the function. f1 should be maximum. So therefore, you will going to get a maximum of value of f1 and for which the value of x2 should be minimum. The minimum value of x2 because you are going to get two values for x2 here. So out of these two, you have to choose only minimum value. So therefore, in this problem, when you put x1 is equal to 0 and x1 is equal to 3, x1, f1 what we have got is 52.5. For x3 is equal to 3, f1 was 24. And even if I put x1 is equal to 1, so you are going to get 40. So therefore, I will choose the value of x1 is equal to 0. For the value of x1 is equal to 0, you are getting the value of f1, the function will be maximum. So therefore, I will going to choose the variable value of x1 as 0 and correspondingly, what should be the minimum value of x2? So here, when you put x1 is equal to 0, you are getting 8 comma 7.5. So 7.5, I'm going to consider it as the value of x2. So therefore, the optimum solution is, look at here at the end, the optimum solution is x1 is equal to 0, x2 is equal to 7.5. So this is how we are going to get the optimum values of x1 and x2. So problem is simple. There's number of steps, not an issue. The only thing is you should write the equations very clearly. Okay. So and you have to get the solutions for this. Okay. So this is the how. Of course, this graph is not required for you. It's only for reference purpose. I have written here. Not required for you. Only thing you can follow this analytical method, computational method, and you can. With the trial you can do. You can show for minimum of 3 or 4 trials you have to show. So x is equal to 0, x1 is equal to 0, x1 is equal to 1, x2 is equal to 2, x1 is equal to 3. So if you create 2 or 3 values, you will go to know. for which value of x1, f1 will become maximum, and corresponding value of x1, which value will be the x minimum value of x2. Those two values you have to take, and those two values we are going to consider it as the optimum values for the problem. This is how we are going to get the solution for a linear programming problem using dynamic programming approach. Okay. So any clarifications, any doubts, you can talk to me, my dear students, because it's very important. You can unmute yourself and you can ask me anywhere. Or if you followed means be able to have the confidence. Of course, we'll go to solve one or two of the problems. Don't worry. This is only just an example I have given today. So please make a note of these things. Okay. Could you able to understand? Any clarification? Anybody? Mithun,
No,
are you
sir.
there? Mithun.
Yes, sir. Yes, sir.
Followed?
Oh, yes, sir.
Dhanush?
Yes, sir.
Do you have any clarification, Dhanush?
No, sir.
So anybody, you can feel free. So no problem here, because the first problem I'm solving it today. So we'll solve some more problems in the further classes. Then you will get used to it. So of course, these things I'm going to post it in your Google Classroom also. So don't worry. But you should practice it. Until unless you practice, it's very difficult. Yeah. Anything?
Okay, sir.
Friends, my sincere request is, see, once it has been given 11 o'clock, so please try to log in within 1 or 2 minutes. If you waste another 10 minutes for me, it's very difficult. So it's happening every day nowadays. I don't know why. Please try to log in within 1 or 2 minutes, okay, not an issue. But if you go beyond the 5 minutes, it's a waste of time for me, waste of time for you also. So I don't expect these things to happen from next class, I'm telling you. Okay. If there is a case, I will go into block off. Once I start this, you cannot enter the meeting mode. I will block that and then I will go into the activity. Okay. So please don't waste my time and your time also. So once it is 11 o'clock, it's actually supposed to start by 10:50, but I give another 10 minutes. You might be having breakfast, something, no problem. But, try to make it within a time so that we can complete the things in we can maximize the time. Okay. So please don't do repeat this. Okay. So log in within 1 or 2 minutes from the scheduled time what I have. Okay. So please practice this problem. So I will going to discuss the same type of problem in the next class also. So afterwards I will go for non-linear programming problems applications. Okay. Thank you very much, my dear students. So please practice these things.
Okay.
Thank you.